The moment Matt Armstrong accepted that the problem was not something simple, the whole rebuild entered a completely different stage. Up until this point, every challenge had eventually led to a solution. A damaged gearbox had looked impossible until it was repaired. Missing parts had been tracked down after long searches. Even creating a working speed key, something many people believed could only be done by Bugatti themselves, had become another success in the rebuild story. Every obstacle had strengthened the belief that patience, careful thinking, and mechanical skill could solve almost anything. That confidence had carried Matt all the way to the runway, where he hoped to finally experience the Veyron at the speed it had been built for. But the sudden engine shutdown changed everything. This was no longer a problem that could be fixed by replacing an obvious broken part or tightening a loose connection. The engine would start, run for only a second, and then shut itself off every single time. It did not matter how many attempts were made. The result stayed exactly the same. That made the mystery even more frustrating, because the car had driven perfectly before reaching the runway. Nothing unusual had happened during the journey there. There had been no warning lights, strange sounds, or signs that something serious was about to happen. It was almost as if the Veyron had decided to stop at the worst possible moment. Instead of giving up or immediately blaming expensive electronic systems, Matt chose to approach the problem like a detective. Every possible cause had to be checked one by one until only the real answer remained. That process would take time, but rushing to conclusions with a car as complex as a Bugatti could easily make the situation worse. Modern supercars are filled with computers, sensors, wiring, and control units that constantly communicate with one another. If just one important module stops talking to the rest of the system, the entire car can refuse to operate correctly. Finding which one had failed was like trying to locate a single broken wire hidden inside one of the world's most complicated machines. That challenge would test not only Matt's patience, but also the experience of everyone helping him. It became clear that this rebuild was no longer about replacing damaged parts. It had become a battle against an invisible fault hiding deep inside one of the most advanced cars ever built. Every new test raised fresh questions instead of giving clear answers. Yet each small clue also brought them one step closer to understanding why the dream of reaching top speed had suddenly turned into one of the biggest mechanical mysteries of the entire project. The investigation started with the simplest possibilities because experienced mechanics know that complicated problems are often caused by surprisingly small things. The first step was checking every fuse connected to the engine and fuel system. On an ordinary family car, this would take only a few minutes, but nothing about the Bugatti Veyron is ordinary. Even reaching some of the fuse boxes requires removing body panels that most owners never touch themselves. Every fuse had to be removed individually, inspected carefully, and tested to make sure it was still working properly. One by one, they all passed. Nothing was blown, damaged, or loose. That result was both good and disappointing. Good because it ruled out an easy failure, but disappointing because it meant the real problem was hidden somewhere else. Attention then turned toward another recent change made to the car. A tracking device had recently been installed, and it was natural to wonder whether it could somehow be preventing the engine from running. Many modern tracking systems include security features that could disable a vehicle if it is stolen. If something had been connected incorrectly, perhaps it was sending the wrong signal to the engine. Instead of guessing, Matt contacted the company that installed the tracker. They explained exactly how the system worked and confirmed it was only a simple 3-wire device with no ability to shut down the fuel system or activate the immobilizer. Another possibility disappeared. Next came the speed key. Since the engine failure happened on the same day the special speed key was used, it seemed reasonable to question whether the key itself had caused the issue. The Bugatti speed key is famous because it unlocks the car's highest speed mode, but many people misunderstand how it actually works. Some imagine it contained advanced electronics or hidden programming that could interfere with the vehicle. Careful inspection showed that the key was simply a mechanical blade without its own electronic coding. It was not secretly controlling the engine. Still, to remove every doubt, the immobilizer system was scanned using professional diagnostic equipment. The results showed that the key was recognized correctly every time. There were no immobilizer faults, no security errors, and no communication problems between the key and the car. Once again, another theory disappeared. Although each test failed to solve the mystery, every eliminated possibility narrowed the search. The list of suspects grew smaller, and one component slowly began attracting more attention than all the others. Soon, all the evidence would point toward a single electronic module hidden inside the Veyron, a part few people had ever heard of, yet one capable of bringing a million-pound hypercar to a complete standstill. By this stage, the search for fault had become much more focused. Every major system that could easily be checked had already been tested, and each one had passed without revealing the real cause. The engine itself showed no signs of serious damage. The ignition system appeared healthy. Both the low-pressure and high-pressure fuel pumps were operating exactly as they should. The immobilizer was not blocking the engine, the speed key was not responsible, and every important fuse was still working. Instead of solving the mystery, each successful test only made the situation more confusing. How could a Bugatti Veyron refuse to run when so many of its critical systems were behaving normally? That question stayed in everyone's mind as Matt and the specialists continued examining the car piece by piece. Eventually, one small electronic unit began attracting more attention than anything else. It was a fuel pump control module, a part that most owners never think about because it normally does its job silently in the background. Yet inside a Veyron, this module plays an incredibly important role. It sits between different parts of the fuel system, constantly deciding how much fuel pressure the engine needs at any given moment. The famous W16 engine is unlike almost anything else on the road. It produces enormous power, and to keep that power under control, the engine depends on perfectly managed fuel delivery every second it is running. If the control module stops communicating correctly, the pumps may still work, but they will no longer know how much pressure to provide or when to adjust it. That could easily explain why the engine started for a moment before shutting itself down. The computer was likely protecting the engine from running with incorrect fuel pressure rather than allowing it to continue operating in an unsafe condition. Diagnostic equipment was connected once again, this time focusing specifically on the fuel system. The results became more convincing with every scan. Communication errors kept pointing back toward the same control module, instead of spreading across several systems. The fault remained isolated to one place. It was becoming increasingly difficult to blame anything else. Still, before spending thousands of pounds replacing an expensive Bugatti component, Matt wanted complete proof. Guessing was never part of his rebuilding process. Every repair needed evidence. Every replacement needed a clear reason. That careful approach had already saved huge amounts of money during earlier stages of rebuild, and now it would once again become the key to uncovering the truth. The team agreed that one final experiment could reveal exactly what the module was doing. It was a simple idea in theory, but the result would surprise everyone standing in the workshop. No one expected such a dramatic reaction from the car, and what happened next would become one of the most important discoveries of the entire rebuild. Instead of replacing the fuel pump control module immediately, Matt decided to disconnect it completely. At first, this might sound like a strange decision. Why unplug a part that already appears faulty? But experienced technicians often use this method to understand whether a component is failing quietly or actively causing problems. Sometimes a damaged electronic unit sends incorrect information to the rest of the system, making things worse than if it were not connected at all. If the module was truly responsible, removing could force the car into a backup operating mode and reveal how the engine behaved without its influence. Everyone watched closely as the module was unplugged and the engine was started once again. What happened next changed the entire direction of the investigation. The engine did not immediately die like it had before. Instead, it continued running. It was far from perfect. Warning lights appeared across the dashboard. The engine management system reported faults. The fuel level reading disappeared, and the car clearly was not safe to drive normally. Yet despite all those warnings, the engine stayed alive. That single moment proved something extremely important. The fuel pumps themselves were capable of supplying enough fuel. The engine itself was capable of running. The real problem was not a lack of fuel, but the commands being sent by the control module. Without the faulty module giving incorrect instructions, the fuel pumps automatically switched into a default operating mode where they ran continuously at a fixed pressure. It was not an ideal solution, but it provided enough fuel for the engine to keep running. In other words, the module had not simply stopped working. It had been actively telling one side of the fuel system to reduce or stop fuel pressure, effectively shutting the engine down. That discovery transformed the investigation from a confusing mystery into a clear electronic failure. For the first time since the engine had died at the runway, Matt finally had solid evidence instead of theories. The feeling inside the workshop changed immediately. There was relief because the problem had finally been identified, but there was also frustration because replacing this particular component would not be as simple as ordering an ordinary spare part online. As the team began searching for a replacement module, they expected to find expensive prices. What they did not expect was to uncover official Bugatti documents, showing that this exact component already had a history of serious failures. That discovery would raise an even bigger question. If Bugatti already knew about problems with this part, why had Matt's Veyron suffered the same failure anyway? The next stage of the project became even more interesting because Matt Armstrong was no longer dealing with a simple repair. At first, everyone believed that the biggest challenge had already passed. The damaged Bugatti Veyron had been taken apart, inspected, and slowly brought back to life. Many of the broken parts had already been repaired or replaced, and every small victory made the team believe they were getting closer to hearing the famous W16 engine run perfectly again. But anyone who has ever worked on a complicated machine knows that the hardest problems often appear only after everything seems almost finished. That was exactly what happened here. As more systems were connected and tested together, the Bugatti began showing strange signs that nobody expected. Small warning lights appeared. Electronic systems behaved differently every time the ignition was switched on, and several parts that looked completely fine refused to communicate with each other. Modern hypercars are far more than powerful engines and expensive body panels. They are filled with computers that constantly exchange information. Every control module depends on another module working correctly, and if one part sends the wrong signal, the entire car can refuse to cooperate. This is very different from older sports cars, where mechanics could often diagnose a problem by listening to the engine or checking a few sensors. With the Veyron, every step required careful investigation, expensive diagnostic equipment, and endless patience. Matt understood this in the beginning, but experiencing it firsthand was something completely different. Each time they believed they had found the real cause, another unexpected problem appeared. Instead of getting frustrated immediately, the team approached every challenge with the same mindset they had used throughout the build. They gathered information, checked every connection, compared readings, and carefully ruled out one possibility after another. This slow process may not seem exciting at first, but it is actually what separates experienced builders from people who simply replace random parts until something works. Every decision had to make sense because making the wrong choice on a Bugatti could cost thousands of dollars and waste weeks of valuable time. That pressure was always present in the background, making every test feel important. Even something as small as unplugging a connector required confidence because one mistake could create even more issues. The viewers could clearly see that this project had reached a completely different level. It was no longer about installing shiny new parts or repainting damaged panels. It had become a battle against invisible problems hidden inside one of the most advanced production cars ever built. That mystery made every episode more exciting because nobody knew what the next test would reveal. Even experienced Bugatti technicians spend years learning how these cars operate, so expecting every answer to come quickly would have been unrealistic. Matt knew this and accepted that solving the puzzle would require persistence rather than shortcuts. As the investigation continued, every successful repair increased confidence, but every new warning reminded the team that they were still dealing with an engineering masterpiece that refused to reveal its secrets easily. The deeper they looked, the clearer it became that the Bugatti was testing not only their mechanical skills, but also their ability to stay calm under pressure. Every hour spent tracing wires, reading fault codes, and verifying sensor data brought them one step closer to understanding the car, even if the final solution still seemed far away. That is one reason why this project captured so much attention. It was not simply about fixing an expensive vehicle. It was about watching determination compete against one of the most complicated automotive systems ever created. Every obstacle became another lesson, proving that rebuilding a Bugatti is never as straightforward as replacing broken components. Sometimes the real challenge lies in discovering the one hidden issue that nobody expects, and at this point in the story, it was becoming clear that such a problem was waiting somewhere inside the car, refusing to make itself known until every other possibility had been eliminated. As more testing continued, the team started paying closer attention to how different systems reacted under specific conditions. Instead of focusing only on the engine, they expanded their investigation to include the transmission, suspension, braking system, cooling circuits, and the countless electronic control units scattered throughout the car. Every module stored information, and every fault code told a small part of the story. The challenge was putting those pieces together into one complete picture. Sometimes a warning related to one system was actually caused by a completely different component somewhere else in the vehicle. That made diagnosis incredibly difficult because the first error displayed on the screen was not always the real problem. It was similar to solving a giant puzzle where every missing piece changed the appearance of the entire image. Matt and the team understood that guessing would only create more confusion, so they continued working methodically. They checked voltages, inspected wiring harnesses, confirmed sensor readings, and compared live data with factory specifications whenever possible. Every successful test eliminated another possible cause, but also increased the mystery because the remaining options became fewer and more complicated. Even viewers who had never repaired a car before could appreciate how much patience this process required. There were no dramatic explosions or obvious broken parts to replace. Instead, progress depended on careful thinking and attention to detail. One small reading that appeared slightly different from expected values could eventually become the key to solving everything. Throughout the process, Matt remained surprisingly optimistic. He often reminded viewers that impossible projects are solved one step at a time, and that rushing only creates bigger mistakes. That attitude became one of the strongest parts of the entire build, because it showed that success is rarely achieved through luck alone. Behind every finished project are countless hours of investigation that most people never see. The Bugatti perfectly demonstrated this reality. Every connector, sensor, and electronic controller had to perform exactly as designed before the car would finally behave normally. Even after weeks of work, there was still no guarantee that the next startup would be successful. Yet that uncertainty also created excitement because every attempt carried the possibility of finally revealing the hidden fault. As expectations continued to grow, viewers began wondering whether this would become the first challenge that even Matt Armstrong could not overcome. After all, every builder eventually encounters a problem that pushes their knowledge beyond its limits. The Bugatti seemed determined to become that challenge, forcing everyone involved to question every assumption and rethink every previous repair. Still, giving up was never considered an option. Every obstacle only strengthened the team's determination to keep searching until the real answer was found. Little did they know, the breakthrough they were hoping for would eventually arrive from a direction nobody had expected, proving once again that the smallest overlooked detail can completely change the outcome of one of the biggest automotive restoration projects ever attempted. The longer the investigation continued, the more obvious it became that this Bugatti Veyron was hiding something far more complicated than anyone had imagined. At the beginning of the rebuild, most of the damage could be seen with the naked eye. Broken body panels, damaged suspension parts, leaking components, and crushed pieces all pointed toward repairs that could be planned and completed one by one. Those kind of problems, while expensive, are still predictable. A skilled mechanic can inspect the damage, order replacement parts, install them correctly, and move on to the next stage. But now the project had entered completely different territory. The car looked almost complete on the outside, yet something deep inside its electronic systems refused to cooperate. Every time the team believed they had removed one obstacle, another unexpected fault appeared almost immediately. It felt as if the Bugatti was constantly staying one step ahead of them. This was no longer a challenge of replacing damaged parts. It had become a challenge of understanding how one of the world's most advanced hypercars actually thought. Unlike ordinary vehicles, the Veyron depends on dozens of electronic control units that constantly exchange information with one another. They monitor engine temperature, transmission pressure, suspension height, braking performance, fuel delivery, cooling systems, steering inputs, and countless other details every second. If even one module receives incorrect information, it can trigger safety systems that prevent the entire car from operating normally. That level of protection is one reason the Veyron has earned its reputation for reliability despite producing incredible amounts of power. However, that same protection also makes repairs extremely difficult because one small fault can create a long list of warnings that appear completely unrelated. Matt Armstrong quickly realized that reading the fault codes alone would never be enough. Every code had to be understood within the bigger picture. Was the warning pointing directly to the broken component? Or was another hidden issue causing the system to react? Answering that question required experience, patience, and countless hours of testing. Every connector was unplugged and inspected. Wiring was traced from one end of the vehicle to the other. Voltage readings were measured again and again to make sure nothing was being overlooked. Sensors that appeared healthy were tested anyway, because assumptions have no place when working on a car of this complexity. Even after all those checks, the mystery remained. Viewers watching the series could almost feel the growing tension because each episode ended with hope, only for another unexpected challenge to appear during the next stage. Yet instead of becoming discouraged, Matt treated every setback as another lesson. He often explained that difficult projects rarely move in a straight line. Progress comes from eliminating possibilities, until only the real answer remains. That attitude became increasingly important because frustration could easily lead to rushed decisions, and rushing inside a Bugatti can become an incredibly expensive mistake. The team knew they had already invested enormous amounts of time, money, and effort into this project. Walking away was never an option. Instead, every failed test provided valuable information that narrowed the search a little further. Slowly but surely, the impossible problem was becoming smaller, even if nobody could see the solution yet. It was this careful determination that kept viewers returning to every episode. They were not simply watching someone repair an expensive car. They were watching a real problem-solving process unfold without shortcuts, where success depended on persistence instead of luck. That honesty made the entire journey feel genuine because every victory had clearly been earned through hard work rather than quick fixes.